so day 2, we've let the dialysis tubes sit in their distilled water overnight. You guys may have it 2 nights. We've also done the potatoes in their different molarity solutions overnight as well. So now we wanted to go through and do final mass. So same as before, I went through, I reweighed the weigh boat. So yesterday it was 5.6. Today I am weighing it at 5.5. So my weight for my weigh boat is 5.5 grams, which means that whatever my mass is, I'm subtracting that out. As I go through and take out my dialysis tubings, they're all listed on top of what they are. We're going to start with distilled, work our way down. As I pull them out, I'm going to kind of give them a little bit of a blot dry of the baggies. We're going to have a little bit of error here because my strings are going to be wet, which weren't the case before. But we're going to go through and just kind of weigh them out. So, and then we'll kind of talk about what you guys should see as we go through this. So as we go through and weigh, so I am looking at roughly 19.3. So it's 19.3 grams. I got to subtract out my 5.5. You guys are going to be doing that. I'm going to put this back into the cup. We're going to go down to 0.2. Same thing. Remember, all of these cups had distilled water on the outside of them. Inside the dialysis tubings, we had 15 mLs of the molarity or the sucrose molarity solution. So what we should hopefully be seeing, and we do so far, they should increase. Think about why. Think about which way water's going to move. Where do I have more solutes? Well, on the outside, I have 100% water. That should help you guys out a little bit of what's going on. It should help you out on where you guys think that graph should be going and what it should be looking like. So my second tube, which is my 0.2 molarity, we are on 21.3. But remember, I have to subtract out that weigh boat. Still 5.5 grams. That's going to give you guys your final mass of that particular baggie. It's going in. We're going up to 0.4 now. Once again, give a little blot dry. Try to get some of the excess water off the strings is basically what I'm going to do. And once again, final mass. We are at 23.8. Still subtracting out the weigh boat. I'll give you your final mass for that particular tube, which is my 0.4 molarity solution. My 0.6. So remember, we left a little room in these baggies because we wanted to make sure if things were going to move through that they actually had room to move in. Things had to move out. There's always room for that. So this is my 0.6 now. I am at, let's go 25. So now I'm at 25. I'm going to subtract out my weigh boat. Back into our little solution. We're up to 0.8. So we're going to say 26.8 is my mass with the weigh boat. Subtract out that 5.5 grams. And my last one, which is my 1 molarity. This was a super sugary solution that we put inside the distilled water. So in the tube, once again, get all that excess out. Go with, say, 28.2. Subtract out the weigh boat. And that's going to give you that final mass. So what are you guys going to do with this now? So we want to look at those particular dialysis tubings. You need to find your percent change in mass. Your formula is there. All your data is there. You're figuring it out. So let's go through and do just distilled water together and talk about what we have there. So we need to first off find my initial mass of just the bag. 19.1, subtract out my weigh boat, 5.6. That means that baggie with the 15 mLs of distilled water in it was 13.5 grams. That was my initial mass of just the baggie. My final mass was 19.3. We're subtracting out my 5.5 grams. It is 13.8 grams. That is going to be my final. Sorry, I'm going to do that in red for you, keep you consistent there. We're taking these two numbers, initial mass, final mass, are the ones I just circled there once you subtracted out my weigh boat. We're putting them into my formula. Final mass minus my initial mass divided by my initial mass times it by 100% change. So my final mass was 13.8. Subtracting out 13.5. And I'm going to divide it by 13.5. And now I'm going to times it by 100. And that's going to give me my percent that there's changing. Now, truthfully, I have distilled water in my tube. I have distilled water in the cup. Distilled water is 100% water. So truthfully, things should be moving back if you think about it. It should be an isotonic solution. It should be equal. There's going to be percent error. The baggie's a little wet. The strings are a little wet. And that's going to add a little bit of change. I have 0.3 grams. That's not a lot. So what is my percent change? I have 2.2%. Just take it to the one place after the decimal point there. 2.2%. It's a positive change that I have there. So it gained a little bit. Well, my strings are wet. The baggie is wet. There might be a little excess water stuck between the creases. So that's not bad. Realistically, in a perfect scientific method experiment, we want that number to be 0. You guys are going to go through with the rest of these. Think about what's going to happen to it. What are my numbers going to look like? You guys are then kind of designing a graph. I said insert it here. What's it going to look like? Probably something like this. Along the bottom, your sucrose molarity, 0, 0.2, 0.4, 0.6, 0.8, 1.0, increasing molarity. Percent change in mass, 0, what's my highest number? Spread it out. Make me a line. Do not just leave me a bunch of dots wherever you think they are. Connect the line or a best fit line between there and let me know what's going on with it. You guys are then going to use that graph to answer the 2 questions that you see below it. So that is dialysis tubing. I'm going to kind of slide these back and we're going to move our potatoes up. And so if you think about your potatoes, the potatoes are a little different because now what we have is we have those potatoes in different molarity solutions. So instead of distilled water being in the cup, I've got sugar solutions in the cup. And what we want to look at is can we find the molarity solution of that potato? Well, someplace it's not going to either gain weight or lose weight along the way. So I just want to go through and just double check my weigh boat again because remember I just had bags in there and they were wet. I want to make sure I didn't change the numbers a little bit. So yeah, we'll keep it at about 5.5. So I'm going to go through, switch my data chart. We're going to the next set. There's my data from yesterday. So that's my weigh boat in blue. That was my initial. My final mass, my weigh boat, is still 5.5 grams. So as we go through here, we'll be finding that final mass the same way we just did our dialysis tubing. My temperature, we took it earlier for you guys. It's 22 degrees Celsius all the way through. You may need that if you're attempting that extra credit question that we'll look at in a moment. It will ask you to find the water potential, and you need the temperature for that. So I'm going to scoop my potato out. I'm going to give it a little blot out of distilled water. I'm going to pop it in there, and I'm going to find the mass. So as we go through, we're looking at about 16 and a half. So 16.5. I'm going to take away my 5.5. And that's going to give you that final mass for that particular potato in distilled water. We'll leave that outside the cup for a moment because I'm going to have you look at a few things as I go through a few of these potatoes. Grab the next one, just give it a little quick blot, throw it in there, and find my mass. So here you're going to notice that now I have to kind of lower the numbers because it's actually a little bit less mass than what I had before. You're going to have to kind of think why. What's going on? Which way is water moving? Where do I have more solutes? We're dealing with water potential, so we're dealing with osmosis here. Here I'm looking at a number of 15.4. So it's 15.4 grams minus my 5.5 grams for my weigh boat. That's going to give you my final number for that potato in 0.2 molar solution. 0.4. Same thing, pull it out. Remember, now we're getting a little bit more sugary solutions going on. 0.4 is going in. It's actually going to be a little bit lighter now. So we are looking at 13.6. Minus my 5.5 from my weigh boat will give me my final mass for 0.4. Put that outside. We're up to 0.6 molarity sucrose. Same thing, a little bit more sugar in them. Should blend that off just a little bit. About, let's go 12.9 on that one. 12.9 grams minus the 5.5, give you that final mass. We're up to 0.8. Let's go 12.2 on that one. Minus out your 5.5. Give you the final mass for 0.8. We're up to the super sugary solution. Pop it in. And I'm going to show you guys something between a couple of these potatoes. I want you to take a quick look at and kind of think about the egg scenario that we did in class as well as we're doing this. Go about 11.4 on that one, minus my 5.5 grams will give you your total mass. So here is my potato for my 1 molarity sucrose solution. See it like this. Here's my potato for that one. If we look at distilled water, they started out the same. They started out exactly the same size. So if we're looking at 3 centimeters, yeah, they're still about 3 centimeters, but look at the diameter of those two. This one, you can kind of bend, it's kind of squishy, it almost looks like a little Cheeto or something. Think about what's happening there. Oh, plasmolysis maybe. Did we lose some water maybe? So you might see some negative numbers along the way when you guys are finding your percent mass. Don't be shocked if you're like, I have a negative number, I must have done it wrong, and then you forget to put the negative number there. You're gonna have negative numbers. Some of your potatoes gained, some of your potatoes lost. This one is really rigid. Sugar pressure, so maybe water moved in. It is rigid. This one is soft. Think about hypotonic solutions, hypertonic solutions, and what is going on with them. So you guys are using the same formula as you did before on part 2 to find your percent change in mass. You're then going to go through and you're going to graph it. This graph looks a little different. You can take your numbers just slide them over, because this is the information that you're gonna wanna use within your graph. So once you find your percent change in mass, move them over to the next data chart. We have our X and Y axis that you guys will be filling in. Take that information and put it into a graph. I kind of gave you one. I said, you're probably not going to be able to edit this one. If you can figure it out, great. Maybe let us know, because I haven't figured it out yet. But you're going to design a graph that looks like this. And I wanted to show you what it looks like, because along my y-axis, I have the 0 in the middle. Oh, this is going to be my percent change in mass. And the reason is because some of the numbers are going to be negative. Some of the numbers are going to be positive. Somewhere along the line, 0, 0.2, 0.4, 0.6, 0.8, 1.0, as you guys are making that line, you're going to cross the 0 point. Wherever it crosses the 0 point means that that's the molarity. So as you're making your little line, you cross your 0 point and you go down. Whatever molarity that is means that's the molarity that that potato is in an isotonic solution. It may be between two numbers. It may not pop up exactly on like, oh look, it's exactly at 0.6 where it hit the 0 line. No, you might have to estimate where it is in between there. But as you go through and build that line, whichever way you're going as you're doing it, wherever it crosses that 0 point, that's where it's an isotonic solution. That is the molarity of the potato, where the outside concentration and the inside concentration of your solution and potato are going to be equal. Okay? To use that, you guys are then putting that number there. What is my molarity of the potato? At what point does it cross the 0 mark? Put it there. As you guys are going through, it gives you a little bit of information. It might look a little foreign to you, but this is why you're going to need your Celsius temperature. You have one extra credit question. So this extra credit question is asking you about the water potential of potato cells. If you don't want to do it, you're like, no, I don't even want to look at all this stuff, go to question 4. Question 4 and question 5 are required. They are not extra credit as well. Only the one that is starred. It is marked red on your Google Sheets that you guys have. I also put above it, highlighted it, that 4 and 5 are mandatory. So you'll answer question 4. Once you build the graph, you'll answer question 5. Once you build the graph. Notice that both of them, I put explain and why with them. So it's not just kind of a yes, no, maybe so answer. You're kind of telling us why you put that answer. Elaborate on it. Okay, any questions, let us know, and we will go from there. Thanks.